question.
Sorry, I forgot to record.
All good. So for my team, I'm on the mechanical wind-up team. The first way we're going to look into having the solar panels store and fold is a rotary system. So as the system spins to unwind them, they'll come out sort of like a flower does and unfurl. I'm not sure about the motors. Originally, the initial idea was to layer them flat and have them come out and across, but that may not be the most efficient choice. So there's more research that has to be done there.
So the solar panels only need to deploy once, right? So they don't need to unwind and then kind of get back into the box or whatever. They can. So is there a need for it to be a motor or even a watch motion?
Not necessarily. The idea behind the two was just to have something that could reliably release it. I mean, with a motor, you can go both ways, and obviously that's not really required. And so there's stuff there that could be taken out. And there's systems that would be able to just do the one-way release. Same with the watch system. That goes both ways, and it doesn't need to.
So part of what I'm asking is, if all you've got to do is get it to deploy once, could you do it with just springs?
We may be able to do it with springs. That was the idea with the watch mechanism. I actually, a couple days ago, took a tape measure and broke it and got the spring out of it. And they've got rotary clock springs in them. And when they're wound up, they can store a lot of energy. And the plan with that was just to have it release that energy in its entirety by shaving down the spring to a length where it would store just enough to get the panels out.
Sure.
So that it would take up less space.
Hold that up to your camera. Let me see what you got. Stop sharing so I can see. Okay, and that's a big tape measure. Here, let me show you. Can you see mine here?
Yeah, it's a lot smaller.
Well, that's a tape measure right there. How much force do you need to be able to push out your solar panel that's contained in 10 by 10 by 10?
We don't need nearly as much as this. Our plan was to cut this down.
Well, again, be careful with that.
Yeah,
that's a spring steel. Spring steel is difficult to cut. So, I mean, if you can buy one of these, I think they cost $1.50 or something like that. You might be able to just take one of these apart, and that might start off your spring mechanism. And if you've got it coiled up into a small box, I think you could probably get quite a bit of energy out of that thing. Does that make sense? And so this one I think is 1 meter long. Oh, it's inches, so it's 32 inches. But so there. I mean, you can see that's quite a bit of energy that you're storing in there. And really, it's just a matter of which side of the spring that you attach to as to which way it's going to go. Does that make sense?
Yeah.
You can make it so that it pushes out. You just have to attach to the other side of the spring.
Yeah.
And so I'm just trying to give you some options that might save you some time. And I think the concentration that you want to spend more of your time on is how does it want to fold. And so look at how thick your solar panels have to be, right? The thinner you can make them, the better, because then you can store a bunch in that space. And another thing, you've got a 10 by 10 by 10 cube. Do you have to start with a cube, or can your cube be part of the solar panels themselves? Does that make sense?
Yeah.
So it doesn't have to have a container. Your solar panels just have to fit within that cube space. Does that make sense?
Yeah. That was actually one of our primary questions, was how the solar panels were going to fit in the satellite.
And so they are attached to the 2U satellite, but they are only allowed to take up 1U of space on the front of the satellite. Does that make sense?
Yes.
Okay. Very good. Any other thoughts or questions?
Do you have any?
When is the next time we have to do this sort of thing?
What's that?
So when is the next time they have to do a review? So actually, Nancy Hall is your mentor, and she will probably meet with you a few times before what's called the critical design review. And the critical design review is going to be at Rochester Institute of Technology on February the 10th. So we will get to see you then in person, and that's when you should have a working prototype that you have tested. And when you're tested, take videos. So take videos, take pictures, because you never know when you're at the critical design review if things will go wrong. But if you have a video showing us how it deployed so beautifully, then that is good evidence for us. Does that make sense? And that will be February 10th at Rochester, New York, at the Rochester Institute of Technology.
Okay.
Yeah.
All right. So, as a beginning, you might start with cardboard. Don't get like the corrugated cardboard. Start with like the cardboard from a cereal box. That's a little bit closer. And by putting that stuff together, you'll get a better idea of how thick these things are. I found that if you do a Google search and say small solar cells, you can buy little tiny solar panels without epoxy on them for like you can get 100 of them for $15. And so it's pretty cheap. And then you're not just working with some other then you're not working with the wrong sizes or anything like that. You can work with the real stuff. Does that make sense?
Yeah.
All right. Okay.
Yeah.
Good job, team. Keep it up.
Yeah.
Thank you.
And if you have any questions, be sure to copy your teacher, but you can email Nancy Hall anytime with questions. All right. Thank you.
Thank you. Thank you.
Yep. Thank you. Have a good afternoon.
And you guys can stay on and watch what Woodbridge is doing as well if you like too.
Yeah. That would be awesome. All right. So the next school is ready to go. And that's in Olympia, Washington. So it's
So from New York to Washington,
it's 3 hours difference from New York to Washington.
Okay.
And it's Mr. Woodbridge's class there. So hello. Olympia, Washington High School.
Hello.
Hi.
How are you doing?
We're doing good. How about you?
Very good. Okay. What you guys working?
So we started with a couple of different designs. We're trying to figure out what is best. So we haven't like come to a final design yet. We're just kind of testing things out. We're trying to find the best possible solution. So we're going to show you a couple different solutions, couple different ideas that we have. I'm going to start with the first idea. So it's kind of like it doesn't have everything on it. So on each face, there's going to be solar panels. But then in the middle, right here, this 3D printed part, is going to be a solar panel that comes up from inside so we can get more power. That's just kind of one idea that we're thinking of. Why don't you guys show the other ones?
For actual like folding of the solar panels, we came up with this design that opens like this, that we could try to incorporate into our like deploying mechanism.
Okay, so I worked on like the extension mechanism. So I came up with like a telescope design. I kind of think it sounded like what you guys were doing before, but it's basically a tube and they're pushed into each other. And I have a spring in the middle. So the idea is that there's a motor on the inside. And that would be pulling this string tight. So it would close like this. Each face. Now this would be a lot thinner and a lot longer. But it would slowly release it out, and the tension of the spring would just release each segment equally. And you would have the solar panel connected to the end of it, in some kind of accordion design that we have that she got pretty good. So that's the idea that I had.
We tried another idea. It's kind of like it's kind of just like folded up. We made it a little too big on accident. I would just get rid of this bottom part, but it would just kind of unfold, kind of like this. And then each of these little pieces of metal is just supposed to represent a solar panel.
Oh,
Very good. I like that. Okay. Now go back to the tube one. Can you show me that again?
Yep. So I have the string at the bottom.
Okay.
One big spring in the middle. The bottom is kind of falling apart. But
And so how does it, using a string, I can understand how it would collapse, but I'm not sure how you would get it to expand.
So it would start collapse. So it would be right here, and the motor would already be like you would have the string wrapped around the motor. And
Okay.
have the motor just unravel at a constant rate, and that would release it. And due to the spring, it would just push out every segment equally, like that.
Okay.
And
But
it would,
how does it push it out? The string is preventing it from pushing out too fast.
yeah,
What's
because
the mechanism for pushing it out?
the string is connected to the very last segment. So if you ravel the string onto the motor, and have it connected inside the motor, then you can just have it unravel, and the tension will just let it out. Does that make sense?
Well, you've got to have, so do you have some kind of a spring mechanism that's
Yeah,
going
there's
to,
spring inside of it.
oh, okay. And
Yeah.
so that sounds interesting. I like that idea. Okay. Very good. All right. Go back to the first one again. The first one was yes.
Okay, yeah.
Okay.
So this one we'd
So,
probably combine that to be able to push this middle solar panel out. And then just on all the faces, it would have its own solar panels.
so how many could you have that would get pushed out?
So we could have one on this side and then one on the other side. And then
Could you have another panel that does that? And so what I'm saying is you've got the four sides, but then you have one that pops up. Can I have another one that pops up?
oh yeah, I see what you mean. So like there'd be one that would pop up, say here, and then there'd be
Sure.
another one behind it that pops up. Yes, yeah, we could probably do that. It would just be more about trying to figure out how small we can make that spring mechanism over there. And I think that
Sure.
would be a limiting factor.
Okay. Well, and it could be, I'm suggesting that the thickness of your panels might be your main complication there, right?
Yep.
Just because, if you've got one panel or several thick panels, the number of panels is limited by that thickness. But if you've got really thin panels, you can get a lot more out of it. Does that make sense?
Yeah.
Okay. All right. And then there was another one. What was the other one?
It was the way that the solar panels would be folding out.
Yeah. Show me that one again.
Yeah. So it's
You
kind
had
of,
a folded one.
yeah, it's like an accordion kind of like sort of
Okay.
thing. There's two tabs
And
at
how
the
do
end.
you want it to deploy like that? What are you thinking?
We
Do you want to go? I was gonna say that if we had the motor in the very middle, it could basically, this would be a lot skinnier, but it would be connected to the inside.
Uh-huh.
And so it'd be connected to the edge of this, and then when this expands, it would just expand with it. So
I'm
any
with you.
type of coordinate design would just let that unfurl.
Yeah, I like that idea too. These are all good ideas that have the ability to do it. Are you guys leaning towards any particular one yet?
I don't think we're leaning towards one specifically. I think we're just trying to find out what is going to be the most efficient.
And I won't be able to answer that. That's going to be something that you guys can work on. You had another one where you had aluminum plates that you'd kind of stitched onto it or glued
Yeah,
onto the
I just
paper.
taped them on. This was just like the very first thing we did. It was just kind of the very first kind of mock idea. Yeah.
Uh-huh.
Well, it just unfolds and then there's solar
Uh-huh.
panels on it. That's like pretty much it.
Okay. And how would you deploy that one? Did you want to use a similar kind of a mast like thing to extend it out, or what were you thinking?
For this one, I don't know if we put a lot of thought into this one. This was just kind of a base idea. I guess we could probably use that to do it because if we just attach it to one end here, as it slowly extends, it would unravel it.
Uh-huh.
That could work pretty well because if we do it on both sides, and we pack it up really good, it would get hit from the bottom and the top, and it would just be extending like outside of the cube set. So we would get like a lot of sunlight.
Okay. And now another thought for you. Imagine so on that last one we were just looking at, if we had that if you look at a mouse trap, it's got like two springs on it.
Yep.
Okay, those are called torsion springs. Okay. Imagine if you had torsion springs on each one of your pieces of metal, right? And you set them up so that they're flat, and this is your folded position. And then when you release it, they would all open up like that. Does that make sense?
Yeah.
And so that's just another method, and you could, so that you're not working with just one type of spring, you could work with a couple of different springs to be able to give you the unfolding of your setup. Does that make sense? And it would work with it would work with both the one that has metal on it and also the accordion idea that you've got. Does that make sense?
Yeah.
Okay. I like what you're doing. This is looking really interesting. Do you have any other questions there?
I don't think I do. Do you guys have any questions? No.
Okay. Another suggestion for you, if you do a Google search for a small solar cell, you can find little, very small solar panels that don't have the epoxy on them, and you can get them for like $16 for 100.
Okay.
And they're about the same size as those pieces of metal that you had on that last piece. And so they're very thin. They're thinner than the metal that you chose, and they would fit. You could get a lot of them fit into a very small area, and that way you'd have a lot of power. Does that make sense?
Mm-hmm.
Okay.
All
Any
right.
other thoughts?
And if you have any other questions, just send them to me, but copy your teacher. And if I can't answer it, I'll send them to Glenn. That's for sure. So, but I like your designs and I like how you're all working together on that. So that's
Excellent.
awesome. Awesome job. Thank you.
Okay.
All right. So the next up is, and we are right on time actually, is Gallatin High School.
Oh, very good.
In
And
Bozeman,
you guys can
Montana.
listen to what they're talking about as well, if that helps.
Yeah, and I'll put it all online too.
Where's Gallatin? I forget.
Bozeman. It's Bozeman, and we are going to have our critical, and we're going to have our critical design review at Montana State University, Bozeman, on February 18th. The professor, that was the email I was telling you about.
Yes.
The professor said it's a go, so that would be really fun. So you can fly into Bozeman. You don't have to fly.
I hope I can be there.
Yeah. Okay.
Okay. Let's see what. So if Gallatin's ready, we are ready.
Okay. Yep.
I've been to Gallatin. Oh no, I've been to.
All right.
I've been to Gallatin.
Yeah.
Then we gotta share our screen.
Oh yeah.
We got a presentation.
The
Hey
team
guys,
is.
how are you doing?
Good, how are you?
Good.
You run your cursor on the bottom and it will have a big green share. Right. Yep, there you go. Perfect.
All right, you guys ready?
Yeah. All right. Gabriel, that's your slideshow.
So for our materials, we were planning on using architectural boards, small solar cells, a 5-volt solar power manager, 3D printed servo hinges and an onboard battery. For the project description, and the main structure of the cube is going to be made out of the architectural board. Four sides of the cube will fold up to deploy solar panels, and the solar panel array will provide it should provide 8.12 kilowatts of power.
So these are some of the prototypes that we've made. The one on the right is kind of how it's going to look when it's fully deployed. The one on the left is what we made one 20 out of 20 centimeters just to get like a better feel for how we're going to fit everything inside. And we plan on deploying these with servo arms that we 3D print, and then also with like hinge springs for the second ones that come out. And so this is that's a 3D image render of our servo arm that we have, and then those are what hinges we plan on buying for the final prototypes for have it deploy out. And then
yeah, so for the solar array itself, we found these off of Google, these tiny 5-volt solar panels. We're gonna probably connect them onto like a PCB maybe, and then wire them all in using the battery to store the power, and then that solar panel manager too, right there.
That's
sorry, what?
That one's the solar panel manager, and that's their Arduino where we're gonna control everything.
And the Arduino as well.
And then our solar panel surface area is 812.25 square centimeters, with the support surface being 87.75 square centimeters. And again, it is expected to make 8.12 kilowatt hours of energy per day. Enough to produce.
How are you getting 8.12 kilowatt hours? That seems like a lot. Maybe I'm misunderstanding.
That's just what we found on Google for how much it produces per square meter. So we just kind of convert
for a square meter.
Per square meter, yeah. So
we just converted that from just from what we got.
Yeah, it might be accurate based off.
I'm pretty sure that that's not right.
Yeah.
And actually, when you mentioned your size of your cube, you said 20 centimeters by 20 centimeters by 20, and it's 10 by 10 by 10. So make sure.
We did the 20 by 21 just so we could like scale everything down to make sure.
But you know it's 10 by 10.
Yeah, we know it's 10 by 10.
Yeah, our final design will be
our final
10 by 10.
We just did
good.
Everything, and to make sure that everything will fit once we scale it down.
Yeah, that's all right. That's good practice.
Okay. Is that all your slides?
Yes.
Yes.
Okay. Go back up one, would you?
Yeah.
Okay. Now I'm looking at your solar panels. Do me a favor. Can you guys do a Google search for small solar cells?
Yeah.
Yeah, sure.
Billings Career Center I tasked the boys there to do that. I don't know if they're listening.
And so what I hope you'll see, because you're using small solar cells, not panels, you should be able to see that they have a whole bunch of solar cells. You can get 100 of them for $16. And these do not have epoxy on them. The epoxy is there to protect the solar cells, but because these are for a satellite, you don't have to worry about protecting the solar cell. Does that make sense?
Yeah.
And so you don't need. That also means that you have they're thinner, and because they don't have the epoxy on them, and that'll save you a lot of. That'll give you some extra space. And notice that they are. Let's see. You can get some that are like. They're a couple of centimeters wide, and then so there's rectangular ones, or there's squarish ones, and then there's rectangular ones, and they're similar priced. So check it out, just because that might be something that works a little bit better for you. Does that make sense?
Yeah.
Yeah.
So are the panels the same size as the solar cells? Or are they way bigger?
Those look like solar. It looks like they have 2 solar cells per rectangle there. And so, but you can get them in different shapes, right? Go up one more slide. Go up another one. There you go. Okay. Now, here you have, so you guys are starting off with boxes, but you, just so you know, you don't have to have a box, meaning your box can be the solar panels itself, and then you can use that inner space to be able to be more solar panels that deploy, whether it's in the same direction or a different direction. Does that work?
Yeah.
Yeah.
And I'm just trying to get you some more surface area to be able to get your so that you can get more power out of it. Is that okay?
Yeah.
Now here you're doing you're using corrugated cardboard, which is pretty thick for your prototypes. If you use like a cereal box cardboard, it's a lot more similar to what you're working with. It's a lot thinner, and you'd be able to get a lot more solar panels into a box that way. Is that okay?
Yeah.
Go down. Oh, you got another question? Go ahead.
No, we don't have a question.
Oh, okay. Go down a slide. Okay. Now, so you're talking about these hinges that you've got. How big are those hinges?
I think they're about. I'm pretty sure they're like 2 centimeters long, and then about like 1.5 wide.
Okay.
They're pretty small.
Well, and part of my question is, do you need a hinge? How much would a flexible plastic or like a tape material, would that work for some of your hinging?
It would work, yeah.
Now, and consider, this is, we're talking about going to space. So what type of paint, what type of hinge would you use that would be able to handle the kind of temperature changes you're going through? So don't just put any kind of tape on there, because like cellophane tape might just rip on the first when you first deploy. So think about it carefully as you go into it. Does that make sense?
Yeah.
And how did you want to use this motor that you've got?
So like it's gonna start up as a folded cube, and so we want to use it to have like the arm kind of like push the side out and fold it up, and then the other side that we have tucked underneath it will fold out with that hinge.
Okay, and I'm not opposed to anything about how you're using it. Do you need to use a motor? Is there any way that you can do it with springs, where you've got it collapsed, so you've stored a bunch of energy in it, and then once you once the satellite deployer pushes it out, and it just opens up.
Yeah.
Yeah, that could work as well.
And I'm trying. There are reasons why a motor might be better, right? Because with a motor, you can control how fast it deploys. With springs, you can make it so that they just pop out, and but then you're going to have all kind of jiggling, right?
Yeah.
But is there a way where you can use some friction or a string or something like that to slow down that motion?
Yeah, we probably could.
Okay. So these are just options. Don't pretend like I've ever built a satellite. I've never done that. So you guys are already up for me. You're already up on some of these ideas. Go back to your picture of your satellite, your deployment. I'm sorry. Down one slide. Up one slide. There you go. Okay. And so one of them is only deploying in one direction. Is that correct?
Yes, I believe so.
and then the other one is deploying in perpendicular directions to itself. Is that right?
Yeah.
Yes.
Okay. And I'm okay with however you want to do that. I think you can probably get more surface area out of the one on the right. Does that make sense?
Yeah.
Mm-hmm.
Okay. I like how you're starting off with cardboard and aluminum foil and stuff. I think that's also really smart. Good job, guys. Now, had you thought about whether you want to have solar panels on one side or both sides?
We've haven't really fully talked about it. Right now we're just thinking about one side, but we'd be open to doing two sides, just depending on. I think the main thing that we're concerned about right now is the weight.
Is what?
Is the weight, like keeping it under weight.
Okay, and that could be an issue. I mean, you're talking about 1.3 kilograms.
Yeah,
that's quite a bit of weight. I think your bigger issue is probably going to be the volume more than anything. Does that make sense?
Yeah.
Mm-hmm.
Okay. Good job. Any other thoughts or questions, guys?
Nothing right now. No.
Okay. So what you want to do is use that volume up as much as possible so that you can get the most surface area once the array is deployed. And the other issue also is not to cause vibrations on the satellite that it's attached to. Does that make sense?
Yes.
Okay. Nice job.
Thank you.
All right. Thank you.
Yep.
Good, thank you, guys. Keep it up.
Always ask questions. Just copy your wonderful teacher.
All right, we will.
All right. Yeah.
Okay. All right. So I think that's it for this.
For today?
For today.
Excellent.
So I appreciate everybody joining us, and especially Glenn. That was great insight. I really appreciate that. And Glenn, will you be able to join us next week?
I hope